Good morning, everyone, and welcome to SciQuil, a show where we discuss science daily news and interesting science fiction stories and ideas. I'm your host, Cywraith, and today I would like to discuss with you a nice little article on space.com about Saturn's Death Star moon Mimas having an ocean. So let's just dive right in. The major finding is to discover habitability conditions on a solar system object, which we would never expect to have liquid water. It's really astonishing. This is a quote from the actual publication here, the lead scientist, V. Laney. I think it's Valerie Laney. This is the actual publication here on nature.com. The article is by Robert Lee here at space.com, and it was published 6 days ago. So let's get into the article. Astronomers have discovered that a tiny moon of Saturn named Mimas may harbor a hidden liquid ocean beneath its thick icy shell and may thus have the conditions for habitability. This shocking finding radically changes the definition of what an ocean moon can be, and could ultimately redefine our search for alien life on moons in the solar system. That's because, at first appearance, Mimas doesn't look like the kind of body scientists would expect to support an ocean. In fact, it doesn't even look capable of supporting such a vast body of liquid at all. The team behind the watery discovery estimates the ocean is located around 12 to 18 miles beneath the ice-crust surface of Mimas. The researchers also believe it is relatively young, having only appeared between 2 to 25 million years ago. Yet despite remaining hidden for millions of years, the ocean appears to comprise at least half of the moon's volume. The major finding here is the discovery of habitability conditions on a solar system object, which we would never expect to have liquid water. The discovery makes Mimas even more similar to its Saturnian moon sibling Enceladus, which scientists had already known has a subsurface ocean. Both moons exist at a similar distance from the gas giant planet and are similar in size, with the ice-covered Enceladus measuring around 310 miles versus Mimas sitting smaller at 246 miles. One key difference between the two moons is that whereas the ocean of Enceladus breaches its surface in the form of massive jets and plumes, the sea of Mimas has yet to crack its icy dust. So the big difference between Enceladus and Mimas, Enceladus is larger, and it has a breach at the surface, or maybe many locations on the surface where the water is leaking in the form of jets and plumes. But Mimas has no such crack, at least none was found by the Cassini spacecraft when it went through. That means that while NASA's Cassini spacecraft was able to fly through plumes of ice spraying from Enceladus to confirm its oceans and even discover some of the complex molecules contained within, the spacecraft was not able to do any such thing for Mimas. Here's a quote from Laney. It's really surprising we haven't seen anything, but the thickness of the icy shell of Mimas is enough to maintain this ocean without any significant activity, betraying it for millions of years. That's why Cassini did not find anything at the surface of Mimas. End of quote. However, that doesn't mean Cassini, which spent 13 years in Saturn's system before purposefully crashing into the gas giant in 2017, wasn't key in assisting in the discovery of the ocean of Mimas. Now we're going to go down to Mimas's wobble. Before we go into this, I want to discuss what wobble is just a little bit. Wobble, the movement of a light source, such as a star, changes the frequencies of light that the star emits. This is the same as Doppler effect for sounds. That makes a fire engine siren change in pitch as it moves past you. A higher pitch when it's coming towards you, and then a lower pitch as it's going away from you. When the star moves towards us, it releases higher frequency light. When it moves away, the light is of lower frequency. So it works on sound waves and light waves. It affects all waves in the same manner. The difference is small, but our instruments are so sensitive to frequency that we can detect a speed of just half a meter per second. That's about the speed of a person walking. If we see this type of rhythmic change in the light frequency emitted by a star, we know the star is being orbited by a significant body. This approach for detecting extrasolar planets is known as Doppler spectroscopy, or sometimes the radial velocity method, because the star moves around in a circle. This is also sometimes called the wobble method. So that's what wobble is essentially. And you can see it being shown here a little bit. Let's get back to our article. Laney and colleagues discovered their initial hints of Mimas having a buried liquid ocean when they used Cassini data to investigate a break in the infamous rings of Saturn called the Cassini Division. I want to pause again and do a quick discussion on what the Cassini Division is. Right here, we have Saturn's rings. The Cassini Division is this gap. You see this black line in here. there's actually basically no rocks floating in this section. And it's because of something called orbital resonance between Saturn, Mimas, and this section. So what happens in orbital resonance is when there is a properly divisible orbital number. For instance, here the rocks will orbit twice for every once that Mimas orbits. There can be an amplification of the speed of the rocks in here every time they're in alignment with Mimas. So I'll say this is one side where they're in alignment. As Mimas travels around to the other side, about 50%, the rocks will meet it there as well and speed up again. So it's like a magnetic propulsion system in a way, but a gravitational one instead. And the rocks just continue to speed up. And as they speed up, they will actually move into this faster orbital lane here. The closer you get to the center of the orbital rings, the faster the rocks are going. Out here they're slower, and here they're faster. That just uh, to compensate for the gravity, and actually the pull causes more speed. So the rocks generally move into this section here, or sometimes they may be ejected if the vector is off, they collide with another rock or something of that nature. Anyhow, that's what the Cassini division is. Let's get back to our article. So in 2010, while aiming to discover if a change in Mimas's orbit could have caused the Cassini division, the team noticed a strange shift in both the moon's rotation and its orbit. The team determined in 2014 that these large librations were either the result of the Saturnian moon having a misshapen, solid rocky core, or a subsurface ocean that would allow its outer shell to oscillate independently of its core. The breakthrough came when the team finally modeled the motion of Mimas and determined a rocky core could only be responsible for the observations if it was elongated and flat like a pancake. So if it was solid, it would have to look like a flat pancake, like a disc. Obviously, that's not what Mimas looks like. So the way Mimas's orbit has evolved since 2014 has also offered support to the global subsurface ocean hypothesis. Here's a quote from Laney. There is no rigid interior that can be compatible with the rotation and the orbital evolution of Mimas. It is a relief to eventually succeed in demonstrating that this is the solution, referring to it meaning that it has ocean inside. Here we go. A waterlogged moon. Not only was the team able to determine that the oceans have only been present for a few million years, but the crew was also able to calculate just how much water is likely present in the moon's oceans. Quote, at least 50% of the volume of Mimas is filled by liquid water. This is a huge amount of liquid water for the size of the satellite. This water appears to be grinding against the rocky core of Mimas, simultaneously getting heated by the friction this action generates. So let's just take a pause here, look at friction. You have a force, say someone pushing a rock this way on, say, some sort of surface, like maybe just a table or something. And the frictional force will be always in the opposite direction. So this is one vector going west, here's another vector going east. Whatever force you apply here, there will be an equal and opposite friction force in this direction, multiplied by this little u here called the coefficient of friction. And the coefficient is based on the material. Whatever happens here is any amount of energy lost in the push is in the form of heat, generally speaking. You're going to have layers of atoms and molecules breaking up in here. There's going to be, electrical forces and the like, mechanical forces that are causing this friction at a microscopic level. And that will lead to energy release, bonds broken, and that causes the heat release. So we have heat being released between the solid and liquid layers as the solid spins around the liquid at a different rate. Let's get back to our article. So this water appears to be grinding against the rocky core of Mimas, simultaneously getting heated by the friction this action generates. This interaction also gives rise to what Laney describes as interesting chemistry, like developing on the Saturnian moon right now. Interesting chemistry is a reference to origins of life. It is strongly believed that there would be craters in, say, a phosphorus stone or something of that nature, little porous stones right against a liquid layer, like an ocean or something, where life would have began. And that would be the appropriate primordial ooze type of environment for self-replicating molecules to begin. That's what Laney's reference is here. Mimas is a small object that looks extremely cold with no geologic activity, and you would never expect any geophysical activity inside, like heating or contact between water and with silicates in its rocky core. says Laney. Finding this happening is really astonishing. Again, Laney goes on to say, for future investigations, he would love to land a spacecraft on the surface of Mimas, or even Enceladus, for that matter. Here's another quote. I'm pretty sure any space mission to Enceladus will also visit Mimas, as they are extremely close and they are extremely similar ocean systems, but at different times in their evolution. Right, so Mimas is very early on in its evolution, 25 million years, and Enceladus is longer, though they don't specify exactly how much longer. What that means is you could take samples from each ocean and then compare. And if you happen to find life in both, you might be able to see different forms or at different times of the evolution to get a good taste of where the origins start at and what their progression would be. Anyhow, there is no planned spacecraft to this area until the Orbilander, which is NASA's trip for 2038, and it will arrive on the latter moon in 2050, so it's a fair distance away. The key takeaways from this are Mimas could be a great place to study origins of life. Landing a spacecraft on both Enceladus and Mimas will not be anytime soon, but there is a mission to be planned for 2038 and landing in 2050, so that's something. Obviously, it would be nice if we had a lot more of these things going on, but that would require a lot more funding, something we could push for as a culture, instead of having our money spent on a lot of other things. So let me know what you think, and I would love to hear from you. I want to read your comments, get your ideas and feedback. Please let me know how I'm doing in terms of distributing the material to you. I am just beginning. I understand there's a lot that I can do to improve here, so I very much welcome your criticisms and try to add them to my talent pool. Anyhow, that's the end of the article. Thank you very much for joining in. Please like and subscribe below, and I'll see you in the next video.